Hey guys, we are into the 12th session of our biostatistics classes. Um, I know that there is a long gap between our previous session and this session, but here on we'll have the videos in a regular manner. And going on into today's session, today's is about calculating the sample size and power of a study. To start with, I'll be displaying the slides which was actually displayed by the ICMR team for the NPTEL classes, and this video is only for the teaching purpose, and I always acknowledge ICMR for providing the slides. And the objectives of today's session will be about understanding the relationship between the sample size and power, and at the end of the session we will be able to determine the sample size necessary to achieve a given power level for estimating a simple proportion and other measures of effect. And for estimating a sample size, we will require what is our study variable that we should identify first. Then we should identify what type of estimate we are going to do, whether it is percentage or mean or ratio. And then we have to know about the expected frequency of factor of interest. What we are going to measure, that frequency we have to know. And then we have to decide on the desired precision of the estimate. We have to know the acceptable risk that we will have to face during estimating, which will fall outside its real proportional value. That acceptable risk we have to know, and we have to adjust according to the population size and adjust for the design effect and for the expected response rate, whether there will be any loss of follow-up, that we have to adjust. And coming on to the alpha value, alpha is the significance level of a test. It is the probability of rejecting a null hypothesis when it is true. At the end of the session, we will be having a class of about a shortcut of identifying the alpha values, this null hypothesis, accepting, rejecting. That small shortcut we will be learning at the end of the sessions. And alpha, as of now, it is the probability of rejecting a null hypothesis. We all know what the null hypothesis is. Null hypothesis is that this if we are actually trying to make out a difference between two groups, the null hypothesis is that there is no such difference as existing between these groups. So alpha value is that when there is actually no difference, we are rejecting the null hypothesis. That is the alpha value. The confidence level is the probability that an estimate of a population parameter is within a certain limit of true value, and the confidence interval is determined as 1 minus alpha. Beta is the probability of failing to reject, that is accepting a null hypothesis when it is false. So beta value is otherwise called as type 2 error. And power of a study is the probability of correctly rejecting the null hypothesis when it is false. So power of the study is commonly denoted as 1 minus beta. Precision of a study is that how close our estimate is to the true value of a population parameter. It is expressed in absolute terms or relative to the estimate. Now coming to determine the sample size for estimating a population mean. The formula goes by n is equal to z square sigma square divided by t square. Here d is equal to z sigma divided by square root of n. So that is why from here only we derived that n is equal to, as it is in the square root, we will be having to square all those values. So that is how we are deriving this equation. And here what is the d? D is nothing but the product of the reliability coefficient and the standard error. That is what the d is. And here is an example of a health department nutritionist who he wants to conduct of how many teenage girls are taking average daily protein intake. So what is their daily protein intake? This is what he wants to do. Now the values he wants to know before starting a study is the desired width of confidence interval, the level of confidence desired, and the magnitude of population variance. So here, for example, he is taking an interval of 10 units wide, and the estimate will be within 5 units of true value in either direction, and a confidence coefficient of 0.95 is taken. And from the past studies, it is known that the standard deviation is 20 grams. So our formula goes by Z is equal to 1.96, which we derived from that confidence interval. We have a chart for calculating it. From that, we have got as for 0.95 confidence interval, this will be the Z value, and sigma will be 20 and D will be 5. So from here we can know the sample size. Now for population standard deviation, that is sigma. Now this sigma, how we'll get from either there will be a pilot study or preliminary sample which will be done for our own study, or we will be getting it from the previous studies, and otherwise we can calculate it by a formula. Sigma is almost approximately equal to range divided by 6 standard deviation. Okay, so if the population is approximately normally distributed, for example, so we can use that the range is approximately 6 times of the standard deviation. So our formula goes by sigma is approximately equal to range divided by 6. Now for calculating a sample size by estimating the proportions, we will we will get it as the same thing as our standard deviation from either pilot studies or previous studies, or from the formula P is equal to 0.5. okay. So in this for the proportions, we will have to use the formula N is equal to Z square PQ divided by D square. In this, the P will be our that probability value, and Q is equal to 1 minus P. So here there is an example. For example, if we want to know the immunization coverage of a community school children, then we will have to see what we have to do. Then from the previous studies, if we get that the immunization coverage is 80% and the precision will be within 4% of the true value, and confidence interval, as we all know, conventionally will take us 95% confidence interval, and alpha will be 0.05. So Z, from this value, we will, as we said earlier, it will be 1.96, and so our formula will be like D is equal to 0.04, since that is 4% from the true value. Probability is 0.80 since it is 80%, and Z value is 1.96. So this is our formula, Z square PQ divided by D square. Now what is design effect? A bias in the variance will be caused due to the sampling design by selecting the subjects whose results are not independent from each other. So one will be influenced by the other. So in this kind of clusters, this kind of design effect occurs when we are using clusters. So that we call it as design effect. So design effect can be calculated after the study completion, but should be accounted for the design stage. At the design stage itself, we should predict that design effect, but the actual calculation will happen only after finishing the study. So the design effect is 1, that is if there is no design effect when taking a simple random sampling. But when we take a cluster, it should be estimated to be 2. And when we want to calculate the sample size for an analytical study, the desired values of probabilities of alpha and beta are taken into case. For example, if we are calculating the proportion of exposed and non-exposed or deceased, from within which we will be taking controls and cases, and the magnitude of the expected effect, that is the risk ratio, odds ratio, everything has to be kept in mind before calculating the sample size. And see, for example, if we are doing a cohort study of OCUs in relation to the risk of myocardial infarction, see how we are going to do it. From the previous study, we come to know that the proportion of non-OCP users having the risk is 0.15 and the proportion of OCP users having the risk is 0.25. This is from the previous study we are getting. And conventionally, alpha will be taking a 0.05 and beta will be taking as 0.2, because for any study, we will be taking the power of the study to be 80%. So from there, 20% will be our remaining value, and that we are calculating in decimals, that is beta is equal to 0.20 is our beta value. And so we are assuming that we are having equal samples on both sides, that is n1 equal to n2. So we'll be calculating the p value, the q value of both the p values and z value for both. And now we'll be arriving at a formula of n of each group is equal to P0 Q0 plus P1 Q1 in bracket multiplied by Z1 minus alpha by 2 plus Z1 minus beta the whole square divided by P1 minus P0 the whole square. Here we will know that P0 is of the non-OCP users and P1 is of the OCP users. So from that we are calculating this Z value, we are calculating from that table, chart Z value table, which will be calculated accordingly. Here we can see that for 95% interval, that Z1 minus alpha by 2 is 1.96, and for 80% of power it will be 0.84. So this is how we are doing it. This is another example. So from this we will be taking out the odds ratio of the required sample size. For each odds ratio we will get each sample size. And now coming to what is the 10% rule. Note that for sample size estimates should be interpreted as providing merely minimum estimate of the sample sizes. And from this we come into account only overall crude association between the exposure and risk. That is, there we will not be taking into confounders into the list. If so, any confounder is present in our study, that should also be influencing our result. That is why we have to consider 10% rule. That is, increase the sample size to 10% for each confound factor which you are expecting. There are a lot of softwares also for calculating the sample size. For example, openepi.com, which we can use for calculating the sample size. So that's all for this session, and the next session will be about selecting of the study population. Thank you.